All right, we're doing 7-6 again, part 2. What has changed is now these radical equations, when we're trying to isolate and clear out a radical, they won't both clear out at the same time. So this has a little bit more work to do. So the first thing we're going to do is we're going to practice foiling an expression that has a radical in it, because this step is required for the next equations. So we're going to write this expression twice. 3 minus the square root of x plus 4 times 3 minus the square root of x plus 4. And we're going to FOIL. So we're going to take 3 times 3 and get 9. Now we're going to take 3 times negative square root of x plus 4. So you write minus 3 square roots of x plus 4. Side by side means you've multiplied them together. Now you're going to come to the inside, and you're going to get another copy of that. Minus 3 square roots of x plus 4. The last part of FOIL is to take this negative square root of x plus 4 and multiply it with another copy of itself. So a negative times a negative is a positive. And remember what we learned back in 7.5. When you take a square root of an expression and you multiply it with itself, the square roots cancel and you're left with the radicand. So the square root of x plus 4 times the square root of x plus 4 becomes x plus 4. Now after you FOIL, to finish out this practice work that we're going to need in a little while, we would combine like terms. So 9 and 4 would be 13. These carry the same identical radicals, so they're like terms. So we get minus 6 square roots of x plus 4. And then this plus x we still have. So this is what we end up with when we FOIL this expression. So now let's get to a whole equation to solve. And as we go through, I will write down by each part the steps that are required to solving these. So the first step to solving an equation with a radical is to isolate a radical. So I'm going to add this one to the other side. When I'm adding this over, I add it as I exactly see it. Nothing about x minus 3 changed. So this step is I'm isolating. So I get the square root of x plus 2 equals 1 plus the square root of x minus 3. Now I'm going to raise each side to a power of 2 because I want to clear my radicals. So I'm going to take x plus 2 underneath this square root and I'm going to square it. And I'm going to take this entire other side and I'm going to square it. So here we are clearing out a radical. This side, when I square a square root, it falls out. So I get x plus 2. This is a binomial expression, so the only way to square this correctly is to write it twice in FOIL. So I'm going to write 1 plus the square root of x minus 3 twice. And I am now going to have to FOIL. So x plus 2 is just hanging out for a minute. 1 to 1 is 1. Plus 1 to the square root of x minus 3 is the square root of x minus 3. Plus when you move to the inside, you get another copy of that. Plus, when you take the square root of x minus 3 times itself, the square roots cancel out, and you get x minus 3. Now, over here I have some like terms that could be combined together. So I'm going to do x plus 2 equals 1 minus 3 is negative 2. There's a 1 coefficient here, so 1 plus 1 is 2. Square roots of x minus 3 plus x. So I am combining like terms. Now I see that I have a radical that still remains. The only way to solve radical equations is to make sure that all the radicals have been isolated. So you have to isolate first, raise each side to a power that matches the index, and if you're left with a radical still, you must repeat the process. So now we need to isolate again. So I'm going to add my 2, and I'm going to subtract my x. So I end up with 4 equals, these drop out, 2 square roots of x minus 3. Now, I want to clear out the radical. So I clear out the radical by squaring both sides. So I get 4 squared equals 2 square roots of x minus 3 squared. So this is 16. This uses the power rule to distribute my 2 because this isn't a binomial. There's no plus or minus here, so I'm squaring each part. So I get 4 times x minus 3. Because this was multiplication, it's still multiplication after you square each piece. I'm going to distribute right here. So I get 16 equals 4x minus 12, and now I'm going to solve this linear equation. So I'm going to add my 12 to get 4x alone, so I get 28 equals 4x, divide, and x is 7. Now remember, this is a radical equation. This answer must be checked. So everywhere you have an x, you must check the 7 to make sure this balances out. And when you do that, it does work. So now we're going to try another one here, practicing this idea again. So we're going to start by isolating. So I'm going to add the square root of 5x plus 1 to both sides. So I get the square root of 2x plus 11 equals negative 1 plus the square root of 5x plus 1. Now what I need to do is I need to square both sides. Because after isolation, we want to work on clearing out our radicals. So this is squaring a square root, so you get 2x plus 11. This I need to write twice to FOIL. So I get 2x plus 11 equals 1 minus the square root of 5x plus 1 minus the square root of 5x plus 1 plus 5x plus 1. So negative 1 to negative 1 is 1. Negative 1 to this radical is negative that radical. The inside FOIL is identical to that. And then the square root times itself knocks out the square roots. Now we need to combine like terms. So we get 2x plus 11 equals 2 minus 2 square roots of 5x plus 1 plus 5x. We still have a radical remaining, so we need to isolate. So I'm going to subtract my 2, and I'm going to subtract my 5x. So we get negative 3x plus 9 equals negative 2 square roots of 5x plus 1. My goal is now to clear out this radical, so I'm going to square both sides. I'm going to take this whole negative 3x plus 9 expression and square it. I'm going to take negative 2 square roots of 5x plus 1 and square it. This is a binomial because it's 2 parts being added. So the only way to do this squaring correctly is by writing twice and FOILing. This side is power rule, square each piece. So negative 2, all squared would be 4 times 5x plus 1, because when you square a square root, it cancels out. Now I'm going to FOIL. So I get 9x squared minus 54x plus 81 equals 20x plus 4. Again, where did the negative 54x come from? Because you have negative 27 and another negative 27. So that adds to negative 54x. Now here you have to recognize that what you have left to solve is a quadratic equation because of your power of 2. We want to set this equation to 0. I'm going to subtract 20x and I'm going to subtract 4. I end up with 9x squared minus 74x plus 77 equals 0. Once I get this equation to 0, the way to solve this quadratic is to factor. So I need to work on factoring this trinomial. Well, I'm going to say that the way to get to 9x squared is 9x times x. The plus here means my signs are the same, and I need to multiply to 77. So I'm going to use minus 11 and minus 7. If I check for 74, I have 63 and 11, which makes 74. I'm going to set each of these factors equal to 0, and I'm going to solve. So I get x is 11 ninths, and I get x is 7. You must check these answers back in this equation. You are more than welcome to use a calculator to do so. When you check these answers, 11 ninths does not work, and you may only keep 7. This is a third one of the type we've just done twice. If you need to practice it, you can do so. The answers that you would get are 2 and 62, but this one after checking does not work. So if you need to practice another one, those are the answers you should get when you're done. Now to finish up this section, we have some here that have different index powers. So if you have a cube root to a cube root, you still want to make sure it's isolated. And since it is, all you have to do is cube each side, because you want to raise each side to a power that matches the index. So if you cube a cube root, it cancels out, so you get 2x squared plus 3x minus 7 equals 2x squared plus 4x plus 6. Now you want to start combining like terms, so when you move over your 2x squared, they cancel out. What you're left with now is a linear equation. So I'm going to subtract my 3x, and I'm going to subtract my 6. So I get negative 13 equals x. And if you check it, it works. Number 9 is the fourth root of x minus 1 minus 2 equals 0. So I got to isolate, got to move my 2. So I get the fourth root of x minus 1 equals 2. I want to raise the fourth root to the fourth power because I raise each side to a power that matches the index. So the fourth root raised to the fourth power cancels for x minus 1. This is 16. I'm going to add my 1, and I get x is 17, which does indeed work.